Hello everyone, welcome back. So, as you've probably guessed by the title, we're going to be talking about the basics of metallurgy. So, I'm going to just jump right into it. You need to know what you're working with. You obviously need to know your equipment, you know, what gas you're using, or even if you're using gas. There are multiple different ways to melt metal, coal, gas, electricity, a lot of different ways. I suppose nuclear too, but generally that gets its own kind of YouTube video. Not generally something my channel covers either. Usually just disasters. But, supposing you have conventional melting systems, most of the time it's going to be gas, so I'm just going to reference gas. You can melt a pretty wide range of metals. I mean, obviously not all of them, but a decent amount. So you need to be conscious of the melting point of the metal that you're working with. So let's say I want to melt copper. I'm going to want to turn up that heat a pretty decent amount because copper has a pretty high melting point for a propane gas burning foundry. Let's say I wanted to melt steel. Well, you guys have seen that before. I'm gonna probably need a chemical reaction of some sort on top of the propane. I mean, theoretically, I think I probably could melt steel with propane. I haven't quite gotten there yet, though. So, I still have a little bit of ways to go, and I need to use some advantages. Now, let's say I wanted to melt aluminum. Well, I'm not about to waste a bunch of propane on aluminum. Aluminum's got a really low melting temperature, so I'm just gonna turn it up, you know, a decent amount just to where the aluminum gets melted, and it's just melted. And I would go on to completely ignore what I just said. Don't worry, y'all are gonna see that video pretty soon, so stay tuned and subscribe if you haven't. It's aluminum, you don't need that. And it's better not to waste propane, because, you know, it's not necessarily cheap. It's not really expensive either, but it's not really cheap. Anyway, I want to alloy, let's say, potassium and iron, because I'm a freak. Yeah, that's probably not going to go so well. They have two vastly different melting points, and the melting point of iron is above potassium's boiling point, which brings us to our next subject, the constraint of boiling point. Potassium, sodium, heck, even lithium, even though lithium actually has a pretty high boiling point considering it's an alkaline metal. These metals tend to turn into fumes first, before the other metal will actually melt, for instance copper. Which is kind of how I wonder how people actually do brass. They must melt the copper first and then throw in the zinc, because if you do it that way, usually it should work, but you gotta be really quick with turning the temperature down on that too, so you know, it's one of those things where if you don't turn it down enough, it's just going to boil out. So, and it really also depends on what things you're working with. So yeah, I mean, these are really important things. In fact, exploiting the boiling point of elements is actually how you separate mercury from its ores, and how they used to do it way back in the day because, well, as we all know, mercury has a really low melting point and also a really low boiling point. And, well, they used to distill it, which is why it was one of the first few metals to actually be known of. In fact, when I was actually melting this fine little sample of zinc right here, which, oh man, I'm really starting to like the look of zinc. But when I was melting this rather fine sample of zinc right here, I realized I needed to really be careful not to reach its boiling point because it's really easy to do. So I was very judicious with the torch, and some of it did end up actually fuming off and burning. Fortunately, I work in a somewhat ventilated garage. If I breathe in too many of those fumes for too long, I'll end up with something called anosmia, which is pretty much not being able to smell. Another few things you gotta really look out for are the constraints of elemental interactions. Put it into layman's terms, how different things act around each other. For instance, I once had this amazing idea, because there's this element called iodine, and it has a really, you know, it's solid at room temperature, you know, standard temperature and pressure, it's solid. I'm like, okay, well that's good. You know, you can sort of turn it into a liquid before it turns into a gas. It doesn't necessarily sublimate, but you know, it does have a very small liquid phase, about 100 degrees Fahrenheit. that is the range, not when it gets there, but pretty close actually. So, you know, iodine has a melting point. You know, there's this other thing. There's potassium. It has a pretty low melting point too, around the same area. I was like, yeah, should try and melt those two together. Before I realized potassium iodide is actually a salt, not an alloy. I'd pretty much just be making table salt, but weirder. So yeah, I mean, you just gotta know how elements interact with each other, what makes what, and what makes what go boom. Because sometimes you might accidentally create something that goes boom. I try to be very careful about that, and I try to, you know, do the chemistry on some stuff. You know, obviously, I did once accidentally create thermite. Fortunately, it was only in small amounts at the bottom of a crucible, but, you know, I try and take precautions whenever I can, you know. I'm not perfect at it, but I do my best. Another few things you gotta worry about are the constraints of toxicity and safety. Yeah, so there's a reason why y'all have never seen me melt cadmium, thallium, interact with mercury at all, or a few other of those things. Arsenic, that's another one I don't intend on melting anytime soon, or being anywhere near. So, you know, just for safety reasons, you know, you want to not touch the metal that might kill you if you touch it for too long. So, you know, cadmium, thallium, mercury, those are the big three in my opinion. I mean, you also got stuff like lead, which is also pretty bad, but because of how common it is, generally we're pretty much told to be safe around it, so it kind of comes as a natural response, you know? Heavy, dark gray metal, yeah, I should probably be careful around that. Now that pretty much covers everything that goes on inside the crucible, but there are other factors you need to take into account. Fire safety, for instance. Y'all saw that one video in my sort of retro season that I did. Y'all saw that one video when I accidentally sort of set the garage on fire a little bit. But then there's also the opposite issue. Freezing. And y'all are probably thinking, what? Freezing? You're melting metals. Well, okay, yeah, maybe it'll freeze inside the crucible. Well, yeah, sure, that's an issue. But the bigger issue here is, the gas freezing inside the tank. Well, more like, yeah, I guess the gas freezing inside the tank. Because of the pressure difference, and because you're letting gas out of a very compressed area, it's going to cool off, especially on the outside of the tank, and you're going to start actually seeing ice form. You get ice on a propane tank, and the gas starts to not want to come over because I believe on the inside it starts liquefying again. Or at least becoming solid. I don't know, I just know that it really decreases gas output when that happens. So that's another thing you gotta be careful of. Some people have taken to putting it in a bucket of water, usually hot water. What you don't want to do is try and direct fire toward it. As tempting as that might be, you take a chance on overdoing it and causing an explosion, which would make your problems 10 times, no, way worse than 10 times worse. But yeah, so pretty much that's everything I gotta say for now. If I think of anything else, I'll probably just make another video for it, because frankly, I think this one's been pretty comprehensive for the metallurgy part of metal melting. I'm gonna do another one on casting. It's probably gonna be the next one in the series, so I will go ahead and shut up for now. Thank you guys for joining me. I hope you guys enjoyed the video. If you did, like and subscribe, leave a comment, all that good stuff. I hope to see you guys again next time. See y'all later.